In this video, we will go over the main topics that did not appear in QR paper 2 together with sample questions from each topic. You can find these questions by clicking on the link in the description below, where you can also find clickable QR codes that will take you to the exact second where the video solution for the particular question appears on YouTube. We've divided the topics into 10 main areas according to the specification, as you can see, and the most important are obviously trigonometry, differentiation, and integration. These are the topics that tend to attract the most marks, and you also get the difficult questions usually on these topics. So we had proof by contradiction in the first paper, so what we would expect in the second paper could be a proof by exhaustion, disproof by counterexample, or proving the summation formula for the arithmetic series. One example is what appeared in June 2019 in QR1's question 10. The first one is using proof by exhaustion, where you consider n being odd and n being even to prove that n squared plus 2 is not divisible by 4. And the second part, you need to give one example where the statement is true, one example where the statement is false, to conclude that the given statement is sometimes true. You could also get something like we did in October 2020, where we had to use algebra to prove that the square of any natural number is either a multiple of 3 or one more than a multiple of 3, whereby you need to split the natural numbers into the form of 3k, 3k plus 1, and 3k minus 1, again proved by exhaustion. Or what we did in June 2022, where we had to use algebra to prove that n squared plus 5 is even for all natural numbers n. Now, algebra and functions is a really big topic. It could include long division, graphical inequalities, transformations of graphs, verbal problem, quadratic, I think that will appear for sure, rules of indices, surds, discriminant, and maybe set notation. That's especially linked with inequalities. So, for example, in October 2020, the first part was to do long division to express the given left-hand side into this given form, and then you had to use integration to proceed. Notice that they expected the answer in the form of a plus b ln 2, so this could be connected with some logarithmic manipulation. Or like October 2020, where we had to determine the equation of the parabola and the straight line and use inequalities to describe the shaded region in the middle. So for transformations of graphs, we could get something really straightforward, like the opening question in June 2022, where we had to determine the transform coordinates for a particular point. Now, I did mention that we expect a modeling question on quadratics. Such example could be the specimen paper QR1 question 6, or what we got in October 2021, the question 12 in QR1. This is linked with modeling. Usually you have to determine the equation of the quadratic and then answer a couple of questions that refer to the particular problem. We could also be asked something on rules of indices, like we did in June 2019, the first question on QR2 paper, or something involving the discriminant, like we did in specimen paper QR2. So here we had a straight line, we had a parabola, and we had to determine the range of possible values for k for which the two meet at two distinct points, so using the discriminant being greater than 0, leading to a quadratic inequality. Now, for coordinate geometry in the xy plane, it could be anything on the circle and its properties. Remember, we didn't get such a question in the first paper, and obviously we do expect something on parametric equations. So for the circle, it could be something like we did in June 2022. So we had to complete the square, find the coordinates, find the radius, and then find the exact length of OP. Or it could be something like we did in October 2020. So we had a straight line, we had a circle. So this is also blending in simultaneous equations and again using the discriminant in order to determine possible values of R, giving our answers as fully simplified sets. So we've got a good opportunity here to connect different topics from algebra and coordinate geometry. And another example is October 2021, again completing the square. We've got a line being a tangent, find the possible values of k. Moving on to parametric equations, we've got an example from specimen paper QR1. We had to use the addition formula to eliminate t. or from sample assessment, again eliminating t to arrive at a Cartesian equation for the curve C, and a very similar question that appeared in October 2021. Again, you are given the parametric equations, x in terms of t, y in terms of t, and you have to combine them to eliminate t. Now for sequences and series, we could get a question on binomial expansion where the power is a positive integer, because we got the classic example with the fractional power in QR1. We could get an arithmetic sequence, and I believe it's going to be a verbal problem. And we could be asked something on recurrence relationship, sigma notation, order of a sequence. These last three subtopics can be combined into a single question. Now, binomial expansion with a positive integer power appeared in October 2020. So it was to the power of 7, and you had to determine the value of a. And moving on to sequences, one of the proofs you could be asked is the summation formula for the arithmetic sequence. Moving on to a simple arithmetic sequence verbal problem. Or you could be asked, just like we did in October 2020, a recurrence relationship. We're working on the fact that it is periodic with order 3, and we need to explain why k could not be 1 and find the value of this summation here. So we need to be familiar with the terms order or period of a sequence, how to use recurrence relationships, how to employ them into summation formulae. Another example is from June 2022. Again, we had to show that this was a periodic sequence, and we had to find the value of the summation of the first 85 terms of this sequence. Yet another example is specimen paper QR1 question 3. Again, a recurrence relationship. We need to figure out what's happening so we can determine the summation of the first 100 terms and then this double summation over here. Now for trigonometry, we didn't get any sine, cosine rule, or area of a triangle questions in QR1. We certainly expect a classic question where the first part is proving an identity and the second part solving a trigonometric equation. It might be the case that we are asked to sketch a trigonometric graph or even the inverse trigonometric functions and their graphs, and we certainly expect a question on the small angle approximation, which, remember, they are given in your formula booklet. So what we could get, maybe a combination with vectors. So like we did in sample assessment QR1, it's a vector questions that calls for you to use the cosine rule. Or moving on to specimen paper QR2, we start by proving this identity, which involves double angles, and then using that to solve the given trigonometric equation. A very similar question that appeared in October 2020 as well. Again, the classic question. The first part proved the identity, the second part hence or otherwise solved. In June 2022, something very similar. You had to use the addition formula in order to arrive at tan x is 3 root 3, and therefore use the given result in order to proceed in solving the given trigonometric equation. Now for the small angle approximations, a classic question would be something like this. The first part showing that this is approximately 8 minus 5 theta squared, and then you could be given the working of a student and asked to comment upon it. Maybe they did a mistake. Remember, we have to be in radians, and the value of theta should be small for the approximation to be valid. Now for exponentials and logarithms, we certainly expect the questions that involve the use of the rules of logarithms, maybe sketching the graph of a to the x and solving exponential logarithmic equations and linearizing exponential data. So in October 2021, we got something like this, a fairly straightforward question that involves using the rules of logarithms to solve the equation. And moving on to June 2019, we had a more abstract question, log a minus log b is log of a minus b, and you had to arrive at a is b squared over b minus 1. Now, in June 2022, you are asked to sketch y is 4 to the x. So remember, this is a plane that takes off like this, always cutting the y-axis at 1. The y equals to 0 line is an asymptote, and therefore solve 4 to the x is 100. Or October 2021, which was on linearizing exponential data. So this could be well connected with straight lines, gradients, a modeling question, and maybe even asked to interpret the values of the constants within the model equation, or maybe evaluate and criticize the model. Now, differentiation is a really big topic, so I would certainly predict for a question on connected rates of change, parametric differentiation, implicit differentiation, And then we've got the product rule, which did not appear in the first paper. A second derivative question, maybe classifying turning points and all of that. Stationary points, points of inflection, and sketching the derivative function. This last bullet point here has never appeared in an actual paper, but it is part of the syllabus. So, for example, in specimen paper QR2 question 8, this is connected rates of change. You need to use the chain rule to set up a differential equation and use it to find the rate of change, for example, here of the depth of water. And in October 2021, they decided to give you parametric differentiation. So we've got x, we've got y in terms of theta. You need to determine what the y dx in terms of theta and proceed accordingly. Or like June 2019, where we had x in terms of y. This is a classic question where you find dx dy, and then you need to manipulate in order to find the y dx in terms of x. So this can be a challenging question here. And moving on to June 2019, QR2 question 13. This is a question that involves you obtaining an expression for the surface area, then using differentiation to obtain the minimum surface area. So this is looking at turning points, maximum, minimum points, and maybe using the second derivative to classify your turning points. In June 2022, a similar question. So again, you had to obtain an expression for the surface area. You had to prove by further differentiation that this is indeed minimum surface. So these are the type of questions that we would expect to appear in QR2. And also in sample assessment QR2, we had a very similar question. So again, obtaining an expression for the surface area and then finding the minimum surface area and the dimensions that will give this. Moving on to October 2021, points of inflection. Remember, the second derivative must change sign in the vicinity of the point of inflection. So they start by asking you to find the first and second derivative, verify that there's a stationary point, that x is 1, and further prove that this is a point of inflection. To be honest, points of inflection do not appear in every sitting of the A-level. However, we cannot rule them out, so it could be something that you will see on your paper next week. Integration. We expect integration as the limit of a sum, something like the trapezium rule, certainly integration by parts, maybe parametric integration and integrating using the reverse chain rule, and partial fractions, which did not appear at all in QR paper 1. What do we mean by integration as the limit of a sum? Well, in June 2022, you had to understand that the summation of 2 over x delta x as delta x goes to 0 is simply the integral of 2 over x dx from 2.1 up to 6.3. In other words, we need to be familiar with the concept that integration is a process of infinite summation. Now for the trapezium rule, we could get this question. I really like this question because it has a nice connection with mechanics. You are essentially being given the values in a speed-time graph. So we use the fact that the area under a speed-time graph gives you the distance, and you had to apply the trapezium in this context to estimate the length of runway used by the jet to take off. Or, like we did in June 2022, the classic question, part A, use the trapezium rule, and then use the answer we obtained in part A to obtain two different estimates here. So these kind of questions can sometimes prove a bit challenging. I did say we expect integration by parts for sure, and this is something we got in June 2022. So we had to use integration by parts in order to arrive at this particular form for this integral. And we might also get a question that involves parametric integration. So remember that the integral of y with respect to x is the integral of y dx dt when the curve is described parametrically. And the nice example is October 2020 question 12 from QR2. Now we didn't get any partial fractions question in paper 1, so June 2019 question 13 from QR1 is a nice example. We have these, we need to split it into partial fractions and then proceed into finding the area, which we need to give in a particular form. So this is covering both partial fractions and then integration with logarithmic manipulation. Now for numerical methods, we got a question on the Newton-Raphson method, so that's done. It's not going to appear again in QR2. However, we do expect something on recurrence relationships, so iterative methods. So a nice example comes from October 2021, and I like this example particularly because it involves derivatives as well. So the first part is differentiate to arrive at this equation here. And then we are looking for a change of sign for the turning point. So we want f dash of x to be 0. So remember, we are always looking for a change of sign on the equation that needs to be 0. And again, it finishes off with the standard last part of using a suitable interval to show that the root is 0.341. So you'll go 5 up, 3415, and 5 down, 0.3405. in order to look for a change of sign and conclude that the root is 0.341. Now for vectors, we do expect a question because there was nothing in QR1. So I've picked two particular examples. The first one is June 19, QR2, question 10. So it involves lambda, and you need to work within this triangle here in order to arrive at the ratio at which n splits OB. Or you could get this type of question like June 2022, showing that the given parallelogram is a rhombus. So this is essentially checking that you know the properties of quadrilaterals and then moving on to find the exact area of the rhombus. I do hope that you find this collection of questions useful. Remember that the link to the PDF containing all the questions together with the QR codes that you can follow to check out the video solutions is given in the description of this video. Wishing you all the best in your exam.